Again, probably the hard part for you is if you are not given the picture. You would have to be able to graph a half x squared plus 1, which, using your transformations from grade 12, shouldn't be too bad. Parabola moved up 1 unit. You'd have to graph the line y equals x plus 5, and by now lines are probably the easiest thing in the world to graph. We've done so many of them with tangent lines and whatnot throughout the years. And you would see that you have this area shaded right here as the part that's in between. And now you have to make a decision. What method are you going to use if you rotate this around the line x equals 5, which I'll draw here in a red line? You could use discs and washers, right, because it's in between. You can imagine taking this green part in your head, rotating it around, and imagining what the shape would look like. Now the question is, should you use your disc method or should you use your cylindrical shell? And this is the first time I think we're doing a cylindrical shell in between two curves. Okay? If you're going to use cylinders going through from left and right, we notice that the height of one of these cylinders is just the line minus the parabola. Does that make sense that that's your height? Your radius, right here in purple, is just going to be the distance from 5 to your line. And how do we find one of our cylindrical shells? Well, it's just the circumference, 2 pi times your radius, multiplied by your height. We also need to find out where our cylinders are going to start and where they're going to end. So your very first cylinder on the left would start at -2. You would keep making these cylinders go along as you're coming until you get to x equals 4. So when we set up our integral, we can pull the 2 pi out in front. Our radius is going to be 5 minus, because this is just your x coordinate right there, right? To wherever that point is your x coordinate. And if we do 5 minus that x, you would get that purple line. When the x is negative, so when the x is negative here, if you would do 5 minus the negative would add that part, you would get the full radius again. So one of the things we're having to think about is whether we're using the washer method or the cylindrical shells, what's my radius? How do I write my radius? It's usually easy math to think about if you're just thinking about the radius. If you're trying to memorize, how do I write this, like from memory, that I should make this 5 minus x, you're going to find a hard time. If you think about the graph and what the radius is, you're going to find it's not hard to see that this is 5 minus x. What's my height? My height is going to be the line minus the parabola. So if I had x plus 5 as my line, and I subtracted my parabola, and I simplify this, I'm going to get -1/2 x squared plus the x, and 5 minus 1 plus 4. That becomes my height. Once you have things set up, what are we going to have to do here? We're going to have to multiply things out, evaluate. If it was a calculator question, you just plug it in, get our answer. One of the nice things about pulling out the 2 pi is that when we do the calculations of the rest, we get a nice number on our calculator. So we can write an exact answer of 144 pi. So the next slide here really gives us an idea when should we use the disc/washer method and when should we use a cylindrical shell if we were trying to figure out what makes our life easiest. If you have a curve f of x and the region that you're doing is under the curve to the x-axis, if we were rotating this about the x-axis, then I would draw this point and this point, and draw my ovals. Oh, I did that too low. Oh, well. Something like that. It makes sense to use the disc method because you see that you would just have to add up a whole bunch of circles. If that same area is revolved around the y-axis, now our cylinders make the most sense because we can just go along our x-axis and add all those cylinders up and we'll get the volume that way. It's much easier than trying to figure out the disc method along the y. Okay? Especially nicer to use the cylinder method if all of your equations are y equals and you're rotating around the y-axis, right? If you're rotating around the y-axis, you need x equals equations to use the disc method easily. So again, now if the area is to the y-axis and you're rotating around the y-axis, then the disc method with y's makes total sense, especially if the equation is already written as x equals. But if you're taking this same thing and rotating it around the x-axis, well, it makes a cylinder already in the middle. It would make sense to continue that cylinder method all the way through. So just to help us see what things look like with both methods, okay? And since the disc and the washer method is technically the only one included in the curriculum, you could get a long answer question like this one, and they would say, well, if you just learned just the basic curriculum, you could use the disc and washer method and get the right answer, and we would expect you'd be able to do that. But we'll also look at how we could do this with this shell method as well, and also look at this question because this is a calculator active question where we need to use our calculator to solve things. So a lot of this would just be typing things into your calculator, but we still have to have the understanding of what's going on. So we've got the graph of the natural log of x and y equals x minus 2. So you could draw a sketch of the natural log of x, and you could draw the sketch of y equals x minus 2. And the first thing is, here's our area. I'll color it in with my crayon. And that area is going to get revolved around the y-axis. Okay? If we're using the washer method, and we take a cross-section like that, you would have an outer radius in blue here that goes to there, and an inner radius in purple that goes to there. If I draw that washer in red, I would have equal points on this side, inside washer, outside washer, inside radius in purple, outside radius in blue. If I'm using the washer method, can you see that all of your washers that would be added would go from the bottom up or from the top down? You're adding them up vertically. You're stacking them vertically in order to figure them out. This is an important visualization for you to figure out if you are doing a dy or a dx in your integral. If you're stacking these washers vertically, then you will be going from here up to here. That means we need all of our equations in terms of y. So I have to take both of my equations and rearrange them. The line, super easy. It's like, no problem. I like lines. I can rearrange, solve for x. The natural log, what would you have to do? You'd have to take e to both sides, get rid of the natural log, or change it to exponential form, and you would get e to the y equals x. First, we need to find our intersection points. Can you see why this is a calculator active question? Oh, we almost got pi. That's pretty cool, but it's not. All of you that won a piece of pie on the pie memorization day, right away like, no, that's only 2 decimals, right? I've got at least 20. That's stuck in your head all day. So in the washer method, we have to look at our y values. We're going to go from the negative 1.84 up to the 1.416. The washer method uses circles. So we've got pi taken out in front because it's a constant. We go from the negative 1.481406. You know what? In your notes, 4 missing there. If you can't read a number, make it up. It really doesn't matter for your understanding. Right? So it's like going to be the same idea. Sorry that some of them are hard to read. Those are y's. That is important. What's our outer radius? Our outer radius is the line. Our line is y plus 2. Notice the y plus 2, the bigger radius is squared, because it's r squared for a circle. Minus the smaller circle, which is our e to the y. That e to the y gets squared as well. And since this is a calculator question, okay, some things that are helpful for the calculator question is I would probably store this as C and store this as D. I would store this answer as A and this answer as B. So when you go to your calculator, you're not having to type in all of those decimal places again. You can just integrate from C to D. Okay, it's not bad to see that again, just to make sure you know how to do it. Not bad to see it if the computer is fast. Here we go. So we've got the natural log of x in one, and the other one was x minus 2. So there's our graph, there's our intersection points. How do I store these values and keep all of them in the nicest way possible? So I'm going to go second, calculate number 5, the intersection. I'm going to find the one on the left first. So I'm going to push enter, 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 and it finds that 0.1581943. Okay? once you've found something on your graph, when you go out of your graph, it remembers what you solved for. But it remembers the x coordinate, not the y coordinate. So if I go second answer right now, it pulled up this x coordinate that I had. I wanted to store that as A, so I'm going to hit my store button and go alpha A. It's now stored as A. If I want B, B was my y value when this was my x value. The fastest way to do that, oops, we want to hit that button first. Hit the alpha button, and then to get to your y functions, you can either plug it into y1 or y2. I'm going to pick y1, and I'm going to put brackets here and go alpha A. What's y1 of A? Negative 1.84. Same answer that we got there. Isn't that cool?
Yeah.
So now I'm going to take that answer, and what did I say I wanted to store that one as? Store as C. Because we use A and B along our x-axis, and C and D usually along our y-axis, so just being consistent with that. So I stored that with C. Now I'm going to go back to my graph and find my other intersection point. Second, calculate number 5, intersect. Enter, enter, enter. 3.14. So, again, store this answer as alpha B, because it'll get that x coordinate right away for me. And now, I wanted to show you the y1 of A. I could do y1 of B, or I could do y2 of B because it's on both graphs, okay? In this situation, y2 is x minus 2. That's some pretty easy mental math to do, right? Is it hard to subtract 2 off of this and get 1.14? Right, that is our other point. This one was just this minus 2. It's a little harder to see in this one than it was. But this one is really easy to see that it's just the same number, minus 2. And I'm going to store that as alpha D. What's nice about having these stored as A, B, C, and D. And on your exam, it would be not bad to show that you stored it as that. That way you're labeling these things. I can now, instead of doing this to this, can you see that this was just C, and this was just D. So when I go to my calculator, and I go math number 9 to my integral, I can go from alpha C to alpha D. That is a lot quicker to type in than typing in the other stuff that I did. I have y plus 2 squared minus e to the y. Of course, there is no y button. So what do you do on your calculator? You just temporarily use x. So bracket x plus 2 bracket squared minus bracket e to the x. Close that bracket. Squared dx. What will this give me? This will give me this part without the pi in front. Okay? Now we have an answer that's as a decimal. If you wanted to, you could take this, push enter, and get our answer, or you could have, well here, I'll do it both ways. Let's say you type this in, because I don't want to arrow over. Do this, I then take this and times it by pi, and I get my answer. I could have, if I had been astute, it's a nice word, and been thinking ahead, I could have put the pi in front and had that like this, and notice I get the 17.099 right away. Sometimes the nice thing about not putting the pi out in front is if that answer turned out to be 12, a nice number, perfectly 12, then I would probably write my final answer as 12 pi and have an exact answer. So that would be my recommendation for not putting the pi out in front. Because with pi out in front, you're guaranteed to get a decimal. Well, not guaranteed, but most likely. Okay? So if you do go to your decimal, 3 decimal places, do you have any units in this question? No. You're not going to lose marks for not having units cubed. But I would say put units cubed because that means you told yourself to check. And that's going to be important because if there are units in a question, you need to include them. Okay, so this is the washer method. This is what we started with. This is what the curriculum expects. Okay? Why would this one be a little bit easier with the cylindrical shells? Well, both equations were y equals to begin with. So if we did the same thing, again, what we have to think about in our cylindrical shells, we've drawn the picture, we've colored this in. If I want to do a cylinder, then this is my height, and this is my radius. And I would start my cylinders here at A, and go all the way up to here, B. And my cylinders would be moving along my x-axis. Since my cylinders are moving along my x-axis, and you're going from A to B, it's going to be a dx integral. And all of your equations would have to be y equals, so when you plug them in, they're x's. Can you see that your radius is nicely just x? So you can just make your radius your x value. Your height will be the natural log graph minus the line. And this time we're going from A to B. Intersection points are the same. Now we're going from A to B. So it's nice I stored all those points right away. That's all in my calculator. It didn't take much longer to do all of those stored in. I can go to my graphing calculator. Okay, I'm going to have 2 pi, my radius, and then here is my height. So again, I'm going to leave the 2 pi out in front right now. I'm just going to do from alpha A to alpha B of x multiplied by the natural log of x minus bracket x minus 2 dx. The next thing I hope they have happen with, I think they do it on Desmos. I'd like to see it on the graphing calculator. On Desmos, when you start a bracket, it chooses a color. And when you close a bracket, it keeps it that color. So you really can see which brackets go together. Brilliant idea. In my own notes, I like to make some brackets a little bit bigger and smaller too, instead of taking out colors every time. This gives us 2.72, so it's not a nice number. What would have been in front times by 2 pi, and we get the 17.099 again. Should be the same answer because it's the same volume, just 2 different techniques of finding it. Advantages, disadvantages. Okay? And how do we decide which method and helping us visualize? Here, I'll go back. I'll start visualizing the cylinder one first because you're still writing. If I'm adding up my cylinders, as I add them up, move from left to right. They stack bigger and bigger and bigger as I go from left to right to make that volume. So then I am going from a value here to a value here along my x-axis. That makes me think I am changing x. So I would have a dx in my integral. And that means that my equations have to be in terms of x. So when I plug them in, I have in terms of x. So that's our setup. We have to, I find with the setup, if you think about how you're moving, along which axis are you moving when you're changing things? And here we're stacking cylinders. Stacking cylinders moved us from A to B. When we look at our washers, if I draw one washer and I stack washers in this situation, I am moving up and down. So now I have a starting point at C and an ending point at D. And I'm changing along my Y. So I would need all of my equations in terms of Y, so they have to be x equals equations. So if I was looking at this question to begin with, I might choose the cylinder method because my equations are in terms of x. So moving along my x-axis is an easier process because I don't have to change my equations. It just so happened in this one, it was not hard to change my equations. It wasn't hard to have a line x equals, or even natural log, x equals e to the y. But that was an extra step I had to do to use the washer method. Sometimes you can't change the equation easily. Okay? Now, for the purpose of your exam, every single one they'll give you can be changed easily because the cylindrical method isn't a requirement of the course. So they would give you one like this, that the washer method is possible. But if you showed you knew the cylindrical method and got the right answer, they're perfectly happy with that, right? It's like, great, you know more math than you should. I'm not going to get slapped on that. No, not supposed to know that math yet. That's okay.